Okay. All right. So we're going to continue on the relative volatility of mixture. Okay, because this is a very important topic for designing of your distillation column actually. Okay. So when you design the distillation column, you need to know about this. Okay, about the relative volatility. So this concept is to give you some idea whether your chosen method of using distillation column for separation process uh, is good, or whether it is good or whether it is bad. Okay, so before for let's say if you go to the industry, all right, so you have the equipment already. Okay, you have the equipment already and you have the ingredients, all right, you have the raw materials and you know what types of product that you would like to have. Okay, but you think that maybe distillation process can be used to separate the mixture that you have, okay, based on your previous knowledge lah, okay, but that is your assumption, okay, assumption, because we try our best in the industry not to proceed on what we assume that we can success doing the separation using distillation without forecasting first whether it is possible or is it not possible. Okay, so if we have that forecasting, then we are sure that separation will occur, or else you're going to lose so much money because you try to separate using distillation column, but it is not successful. Okay, so that's why learning about calculating the relative volatility is very important to determine whether the process or separation process can be achieved using distillation column or not. Okay, all right. So the symbol for relative volatility is given by alpha, alpha, right? So the value of alpha. So you want to know whether it is good, the value of alpha must be greater compared to when your value of alpha that you calculate you're going to get a less number, less value, so it represents poor separation. Poor separation doesn't mean that separation cannot be occur. Okay, so it depends. What does it mean by good? What does it mean by poor? So we have to analyze first the value. Okay, so it is mentioned here. Okay, definition you can read later. So it represents the ratio. It's just a ratio. Ratio means a value only, no units. Okay, so the ratio of the concentration of A in vapor to the concentration of A in the liquid phase. Because when we talk about a distillation process, it's involved liquid and vapor. Okay, so the contact between liquid and the vapor. All right, and we are talking about a mixture. Let's say we are dealing with binary mixture. Okay, binary mixture means you have A component and B component only. Okay, so you can have multiple components, no problem. But for your level, we just want to discuss a mixture or binary mixture only. Okay, so you have the ratio of concentration of A in the vapor to the concentration of A in the liquid. So this is the one that we are talking about. All right, and then divided by the ratio of concentration of B in vapor to the concentration of B in the liquid. Okay, so you're going to have this formula. So you manipulate this, you rearrange the value, you're going to get this term lah, which is YA multiplied by XB equal to YB multiplied by XA. So bear in your mind, yeah, Hisham, why the symbol Y here represent vapor, yeah? Concentration of A in vapor form, okay? And when you have X, it represents concentration of liquid A, okay? Liquid A, or A in liquid form, okay? So if you can get the value here, you have the concentration for both, four of them, you can just get your alpha, which is your relative volatility of a mixture A and B. Okay, but normally in the calculation, you are not given directly, maybe. Okay, you can also use the partial pressure to calculate your relative volatility of the mixture. Okay, boleh juga ya. But based on these two formula, okay, later we can manipulate again if you have the textbook. Do you have textbook, Hisham?
No.
You don't have textbook? Okay, I'll share with you the ebook. Okay, but that one is old version. But you can still refer to the ebook. Okay.
Okay.
All right. So this is the other formula. If you refer to your textbook, the first formula here, okay, can be manipulated again to get the other formula here. But if you see here, the term is quite different than what you have here. Okay. So why do we need to use this formula? There are many ways. Okay. Kalau you lihat this one, okay, you have alpha, y, x, you have 2y, 2x, and 1 alpha. Altogether, you have 5 variables. Ada 5 In one equation, you have 5 variables. Alright. But if you look at this, okay, look at this equation, you have y, you have x, okay, just xa, no xb, alright, and then you have alpha AB, which is the relative volatility of A and B. Okay, you can just use capital A and capital B here. There's no problem. Okay, so you can replace the small alphabet here. Okay, so in this one equation, you only have 1, 2, 3 unknowns only. Can you see? Here you have 5. Here you have 3. Okay, so when you have 3 means that you can reduce you can reduce to solve maybe the two unknowns to get you can reduce okay, let's say you want to find alpha, here you need 4 unknowns. Okay, 4 unknowns to be solved to get your alpha. Here you only have 3 variables, so you want to know 1, you have to solve 2. Okay, if you want to find y, you have to solve alpha and x. If you want to have alpha, you have to solve xa and ya. So it depends on what you want to solve for the given problem. Okay, all right. So why do we need this? Okay, why do we need this? Okay, separation of components for distillation process depends on the differences in the volatilities of the leads leads to the solution to be distilled. Okay, you are looking for alpha value which is greater than 1. So if you have greater than 1, you're going to have good separation using distillation column. But if you have less than 1, you're going to have poor separation. Poor separation means what? You can still separate, but the purity of your separation, the purity of your product is very small. Okay, for let's say you can just achieve 40%, 30% recovery. So that is not that good. Bila kita kata separation, you need to have a good separation, at least good separation. Good separation means that maybe you can have 80% of purity that you want, or maybe 90% of purity that you want. So your alpha can be a number less than 1 where you get poor separation or good separation more than 1. Okay, so if you calculate the alpha and you get the value of alpha equal to 8, so that is much better, kan? Alright, so that represents, oh, based on the alpha that I have, I'm confident enough to use the separation using distillation method. Itu maksudnya. Because we have an alternative. You have so many choices. You can use gas separation process. You can use maybe liquid extraction process. And this one is distillation process. So which one is good? So you need to analyze your mixture before you can achieve to separate the component A and component B. So the objective here is actually we want to achieve you have a mixture of A and B. So kita nak A pure and B pure that you're going to get towards the end of the process. So that is why we need to have the value for relative volatility. Okay? Understand?
Yes, sir.
Okay, so if you don't understand, you just interrupt me, okay? All right. Okay, so what's the use of the last formula here? Okay, what's the use? So other than try to find your alpha using the first formula, the second formula, you can use the third formula also. Okay, it depends on the questions. What do you have in the questions? So if you have the value, then I think the first equation is easy enough for you to substitute if you have the values. Okay, but if this is not enough, you can try the last one. Okay, so we can look at the example later. Okay, so this is one way. This formula is shown to you due to what you want to solve actually. What do you want to solve? Okay, so let's say you want to find the components or the vapor components or vapor concentration of A. You are given the liquid concentration of A. Okay, and then you're also given the relative volatility of the given mixture. So you can solve for your concentration of vapor for component A. So that's the thing actually. Okay, so by using, so this is what we call the concentration of vapor A in the terms of alpha. Okay? Alpha and X. Itu maksud dia. Okay, so let's proceed to the next slide. Okay, next slide is the exercises that you have. Okay, you have to, this is the basic actually. Basic means that what should I do if I were to have these informations only? What should I do? Okay, so look at the questions. Okay, look directly to what you have to find. First part, you need to calculate the equilibrium composition of vapor and liquid. Okay, so that represent YA and XA. Okay, so this one can be XA and this one can be YA. But if you talk about compositions of vapor, it doesn't mention about A or B. Therefore, you need to find YA, YB, and for liquid, XA and XB. Itu maksud dia. Okay. Now,
kena cari kedua-dua komponen lah.
Yeah. Alright. Dia suruh you cari YA, XA, YA dengan YB, XA dengan XB. Sebab dia tak sebut pun komponen A. Kalau dia sebut komponen A, senang. Maksudnya dia suruh cari YA dengan XA sahaja. Okay. So dia ada mixture. You have the mixture heptane dengan octane.
Okey.
So dia you represent heptane pakai A, octane pakai B. So this is a mixture of ataupun dipanggil binary mixture. Okay, and it is separated at the constant or operating pressure you adalah at 1 atm. Atmospheric pressure sahaja. Okay, So this is what you get. This is what you have actually, not what you get, what you have. This is just vapor pressure of pure component. Okay, vapor pressure. And the value here is the Kelvin for the temperature. And this is the vapor pressure of pure component B. Dia bagi vapor pressure je. So macam mana nak cari X? Macam mana nak cari Y? Okay, so you kena pandang macam mana nak cari dulu. Okay, teruskan sebab because you need to see the overall picture first before you can arrange the strategy to solve the problem. Jangan selesaikan problem dan berfikir, oh next what to do, then it's going to be difficult. Okay, alright. The second one, boiling point diagram for the system. Okay, and then equilibrium curve for the system, and then calculate alpha, and then condition of the mixture. Alright, so these are related to one another for your understanding. Okay, because of what we won't ask you this type of questions in the ordinary semester because it takes quite a long time to solve this problem. But who knows? This semester, your ODL, you might get this type of questions. Okay, so it depends, and I don't know what types of questions that can come out, and I have to prepare you for this. Okay, so let's say equilibrium composition of vapor and liquid. What is given is only vapor pressure, okay, and the temperature. So what to do? So you have to go back to the previous notes. Okay, previous notes. All right. So look at it. Okay, what formula that you want to use? Okay, this is vapor pressure. Okay, vapor pressure of pure A, PA naught. Nampak? Can you see? Tengok ni. This one. Okay, kita nak kenal simbol dia. Kenal? Okay, so you ada PA naught. You juga ada PB naught kalau perlu. Kan? PB naught ni. Simbol. Because dalam you punya ini, dia bagi vapor pressure, pure component A, pure component B with the temperature. At certain temperature, you are given the vapor pressure of pure component A and pure component B. So balik pada your understanding before, saya undur notes tu. Okay, so this is vapor pressure of pure component A at certain temperature. And then kalau you pandang satu lagi, this one is the vapor pressure of pure B at certain temperature. Okay, so nak kira apa? Your job is to actually find XA, YA. Okay, dan at the same time you need to find XB dengan YB. Okay, remember that we have learned before about the mole fraction. XA tambah XB is equal to 1. Betul? Kalau you tahu XA, you tahulah XB kan? XA, nak tahu XB, hanya 1 minus XA. Okay, kalau you tahu YA, you tahulah YB. Because YB is equal to 1 minus YA. Okay? And, so kena baik kat sini. Yang ni partial pressure. This one is pure. Vapor pressure of pure A. So you kena nak belajar topik ni, kena kenal dia punya teori dulu, fahamkan sedikit sahaja relationship kenapa perlu. Because you punya for the ODL for your semester ni, it's still open book. Okay, so it's easy for you to find information and then it's easy for you to follow if you know where to find. Itu je kan. So kalau tak tahu mana nak cari, susah lah kan. Senang macam mana pun soalan tu. Buka lah buku pun. Tapi tak jumpa-jumpa. Okay. Alright. So, pergi balik pada question. You kena buat 4 kolom dekat sini. Tambah lagi 1 kolom, 2 kolom, 3 kolom, 4 kolom. First column untuk XA. Second adalah untuk YA. Lepas tu, ataupun you boleh buat XA dengan XB. Lepas tu, you tambah 1 kolom lagi. YA dengan YB. So, you kena completekan exercise ni ya. Nanti you kena submit kat saya ya. So, you dengar baik-baik. Okay. So, how to find XA? Yang ini ada value. XA dia ada value ya. So, macam mana? Yang ini untuk vapor pressure. Okay. Temperature adalah 371 Kelvin. So, patah balik ya formula. Okay. Alright. So, berapa pressure yang you boleh dapat? Okay. Kalau you tengok sini, untuk Dalton's law, you ada satu equation. Rod's law, you ada satu equation. Apa beza dia? Dalton's law, Rod's law, you perlu partial pressure. Dan you tak ada. You tak ada maklumat ni. Partial pressure. Okay, jadi simpan dulu. Alright. Yang ini pula, you juga tak ada partial pressure. Tapi, you ada total pressure. Total pressure of the system, which is 1 atmospheric pressure. Kan? So, kita ada maklumat tu. Okay. Now, tengok equation yang bawah ni. Yang bawah ni. Okay. Tengok equation bawah ni. You boleh cari YA kalau you tahu XA, P0 dengan PT. P0 ada dah. Okay. So, how can you find XA kalau you dah ada P0? Macam mana? Kat sini ada relationship ada relationship. PT ada relationship. PT adalah PA campur PB. PT adalah PA campur PB. So 1 atmosphere, okay, PA ni berapa? PB ni berapa? Okay, kena fikirlah. Kena cari jalan untuk fikir dulu. Alright, fikir dulu. Okay, so kat sinilah formula yang you akan guna. Okay, so just tengok the next ni. Okay, so ada solution sebenarnya. Okay, saya nak you work out. Okay, dah ada dah solution tu. Saya nak you work out how to find the value of what you are supposed to have lah. Ni kolom ni. Ini you kira sendiri tau, berdasarkan formula tadi. Okay, so saya nak you work out macam mana nak guna formula. Tunjuk saya satu sampel saja cukup. Ya. Sebab jawapan dah ada. Saya nak you tunjuk jalan kerja you satu sampel saja atau 2 sampel. Contoh, how to get this row. Okay. Tunjuk saya. Ataupun how to get this row. Okay. So, you tunjuk contoh tu, you just mention to me. At 377 Kelvin, okay, XA is equal to this value based on the calculation that you going to do. Itu je. Okay. Saya nak you tahu macam mana dapat. Okay, so just choose 2 sampel sahaja, cukuplah. 2 sampel untuk tunjuk pada saya. Oh, saya berjaya dapat value ni. Dia macam tu. Saya berjaya dapat value ni. Okay. Kalau you pandang balik, XA campur XB equal to 1. So, XA tambah dengan XB equal to 1. Jadi, cari satu saja XA, maka dapatlah XB. Same thing with cari YA, maka dapatlah YB. Okay. So, you dapat dah. Okay. Now, nak cari jawapan alpha. Kalau nak pakai alpha, you boleh guna 4 value ni menggunakan equation yang pertama tadi. Yang ada XA, YA, X, B, Y, B, terus dapat nilai ni. Okay. Alright. Now, dia tanya, kenapa, macam mana nak cari boiling point diagram for the system? Okay. Satu lagi, equilibrium curve for the system. Ada dua dia nak. So, boiling point diagram of the system is this one. Bentuk ni. Bentuk ni. Yang ini equilibrium curve. Okay. So, bezakan. Right. So, this one, macam mana dapat titik yang warna gelap ni. So, how do you get this value? So, tengok at one temperature, you akan dapat bentuk macam ni. Ini adalah satu pasang. Purple dengan blue ni satu pasang. Okay. Purple dengan blue tu satu pasang. Yang ini satu pasang because they are at same temperature. Okay, they are at the same temperature. So, saya nak you buat koordinat ni dalam graf ni. Okay, you guna je dalam nota yang you ada tu, you just label. Ni value yang mana? You jot down the value. Dia koordinat ni. Dia sepasang koordinat, sepasang koordinat, sepasang
setiap
koordinat.
point.
Setiap point. You just label. You label belah sini. Tak, saya nak you buat pasangan ni. Maksudnya, ni nilai X. Okay. Sorry. Tajuk bawah dia nanti saya besarkan.
Saya label untuk nilai X sajalah.
Nilai X saja. Dia ni, okay, pandang betul-betul Okay, kalau you rasa X ni yang mana ni? Yang ini, 0.2. Mana? 0.2, mana 0.2? X. Kecil sikit lah. Mana 0.2? X.
Yang suhu.
Ini 0.2. Yang ini 0.3 something.
0.34.
Okay. Sebenarnya ni pasangan dia. Nampak? Okay. Ni pasangan dia. Alright. Semua baca. Okay. Yang ini, yang gelap ni adalah value for XA. Yang merah ni adalah value for YA. Okay. Dan apabila when you talk about value of XA dengan YA, XA and YA, they are always in equilibrium. Value that you get here, they are always in equilibrium at same temperature. Okay. So that's why you can get the boiling point diagram for A and B at 180 atm using but at different temperature. Okay. So ni sketching lah, you kena faham je macam mana dapat. Okay. So dia bukan dapat cara macam ni. Dia bukan dapat purple. Tak. Dia sebenarnya dapat at constant temperature. The blue one is the liquid. The purple one is for the vapor. Okay. Faham Okay. Now, from here, you akan dapat ni. Inilah diagram that you will use almost all the time for distillation. This is called equilibrium diagram. Equilibrium diagram pula, dia ada purple saja. Purple only. And one point here represent the 2 points here. Tahu? Okay. Satu point kat sini represent macam ni. So, you ada 0.29 dengan 0.45 contoh. Yang ni kan you akan dapat vertical punya value. Betul? You buat vertical kan? Ni you tarik ke bawah. Lepas tu yang ni you tarik ke bawah. So, yang belakang ni is YA. Yang depan ni adalah XA. Okay, so XA dan YA terpisah dalam boiling point. Tapi dalam equilibrium curve, dia combine jadi satu koordinat lengkap. Maksudnya paksi X, the X coordinate, X axis adalah X values. and then y-axis represent y value. So you akan dapat y value ya daripada sini. Okay, ni ya, and then dia punya xa adalah di bawah. Ni, itu cara you baca. Okay, any question?
No.
No faham Okay.
Straight line tu?
Straight line ni, okay. Alright. So in this equilibrium diagram, the axis that you use represent the fraction. The fraction. So the mole fraction. The mole fraction, the highest value is 1. For mole fraction, the highest value is 1. Contoh, XA, okay, XA plus XB, you get 1. YA plus YB, you get 1. Okay, so this line, solid line here, represent the 45-degree line. Nak tunjuk pada awak bahawa pemisah ini adalah pemisah yang sama bahagian dia. Satu maksimum. Jadi dia diagonal kepada value itu. Okay, kena buatlah. Later kita akan guna. Sebenarnya yang purple ni je lah yang you punya equilibrium curve. Kita panggil yang purple, the purple is called equilibrium curve. The solid line here is called 45-degree line. So you boleh label here, buat macam apa? Buat macam sudut macam tu, letak 45. Besar pen saya. So you tulis je lah 45. Tak nak dah dia. Tak apa. Okay. Alright. So you just tulis 45 degree line. Tapi kat sini y dia represent vapor mole fraction of vapor A. Sini paksi X dia mole fraction of liquid A. Dia A. A dengan A. B tak main dah kat sini. B tak main. Okay. Sebab apa? Kenapa B tu kita tak kisah? Sebab dah cakap tadi. You know XA, you should know XB. You know YA, you should know YB. So, kenapa nak sibuk-sibuk dua-dua nak tahu supaya dapat sesuatu yang kata apa? Over data. Data yang berlebihan. Tak guna. So, kita cukup-cukuplah data kita tu. Okay? Alright. So, saya nak you settlekan, fahamkan. Actually, what you need to do is get graph paper. Ada graph paper tak? Ada. You tak PKPB kan?
Sekali KPB.
You sama. You duduk mana?
Kedah.
Masih PKPB? Oh, okay.
Tapi negeri tak? Semua kena.
Tapi boleh keluar pergi kedai kan?
Boleh je.
Okay tu. Taklah macam dulu kan, terperap dalam rumah. Okay.
Awal tu.
So, guna kertas graph. Okay, guna kertas graph. You kena practice you punya soft skill. Kalau dalam exam betul, speed memainkan peranan untuk you menghasilkan graph tu, tangan you tu kena bekerja. Tangan you kena bekerja. Okay. Jadi, saya nak you buat di atas kertas graph. Lukis atas kertas graph dan label satu set ataupun dua set saja. Labelkan. Yang ini memang kena buat. Because saya nak tengok you guna yang ni, make sure you guna kertas graph. Sekurang-kurangnya 70% daripada kertas graph itu adalah graph awak. Dia tak boleh buat comel-comel kecil. Tak mau. You kena buat sekurang-kurangnya 70%. Permukaan graph tu you guna untuk draw. Okay? So, kena practice. Okay, so last one. Saya tak ada nak ajar banyak sebenarnya. Just nak make sure you faham apa berlaku saja. Okay. Alright. Okay. So, alpha tadi kita nak bincang. Sekejap. Lupa. Ni alpha. Tengok alpha dia. Tak sama kan? Dia buat temperature kan? Alpha here is
Ha.
1.95, tiba-tiba jadi 2.03, 2.05. Maksudnya alpha is not constant, kita panggil. Yeah. So ada case you can get constant alpha. Ada case you akan dapat yang non-constant alpha. Okay. Tapi if you look at the alpha, semuanya greater than 1, betul? Apa maksud greater than 1?
Good separation.
Good separation. So the separation process is possible, kita panggil. Good separation and the separation process using distillation is possible. Itu je. If you get less, it is not possible. Kenapa nak buat juga kalau dah tahu tak possible? Ini decision making. Bila you nak jadi engineer, this is your decision making part. So you ada knowledge, you calculate manually and then you give the decision. That's the function. Okay? Tapi if you don't have the knowledge, you just receive the instruction, maksudnya you are not category the decision maker in that particular company. Maksudnya kena belajar lagi lah, meneruskan perjuangan. So kalau nak jadi technician je, setakat level you have the diploma qualification, you will receive the command from the top. You cannot make any decision. So tak boleh complain lah kalau orang arah-arah you. Tak boleh complain because you adalah level technician. Tapi if you further your study, you take your degree, you boleh jadi engineer. So level engineer, you are the decision maker. Gaji besar, boleh buat keputusan, boleh suruh orang buat kerja. So buat pilihan lah, nak sambung belajar ke tak? Nak sambung belajar tak?
Sambung kot sampai degree.
Sambung lah, sekarang ni musim PKP ni kan, baiklah sambung, kerja pun tak ada. Sambung je belajar, dapat belajar. So engineering ni, it doesn't matter whether, well, it depends actually, diploma dengan you punya degree, sama ada you want to further in the same area ataupun you nak shift area. Tak ada masalah. Sebab we have some students, their degree in chemical engineering, diploma in chemical engineering, tapi tiba-tiba dia rasa dia minat nak buat business. So dia apply for degree in business. Dapat je, survive, okay je. Maksudnya dia bolehlah nak tukar bidang, tapi nak teruskan lagi baik. Dia macam tu. Okay. So, okay. Soalan tadi tak jawab. What is the condition of the mixture? Dah tahu. Dah tahu nilai alpha yang tak constant dan kemungkinan ada alpha yang constant. So, dia akan patah balik pada nota sebelum ni. Okay. So, if you have the value of alpha, you boleh sambung nota sikit ya kat sini. If you have constant alpha, if you have constant alpha, you are talking about having an ideal mixture. IDEAL. Ideal mixture. If alpha is constant, maksudnya value remain the same for all temperature. But if you have alpha which is not constant, the opposite lah. Not constant for every temperature, you're going to have non-ideal mixture. Itu je jawapan dia. So they represent something actually. Okay. Alright. So I think that's all for today. So saya nak you buat latihan ni sedikit, tunjuk pada saya, and then bukan tunjuk lah, you buat. Okay. So jawapan dah ada. Tak ada hal. Cuma graf ni buat atas kertas graf sendiri. Calculation ni tunjuk dua macam mana dapat. Okay. Yang ini tak payahlah. Tak perlu. Okay. Nanti submit dekat YouFuture. Esok esok saya nak you submit dekat you future during your class time. Boleh?
Boleh.
Kat you future bahagian assessment, nanti you submit lah kat situ. Saya akan bagi nanti. Yeah? Alright? Okay, so I think that's all. Unless you ada soalan nak tanya saya.
Yang condition tu boleh
Condition tu
ideal
yang
dan
tadi?
non-ideal saja ke?
Yeah, that's all.
Kau kena terang juga.
Dia itulah penerangan dia. You kena sebut the condition, apa tadi soalan dia? Okay. Condition of the mixture is non-ideal mix. Non-ideal mixture since
alpha isn't constant.
Alpha is not constant. Macam itulah. Habis cerita. Okay? Alright, so next class, next class, saya continue ni next week lah. So next week kena heavy sikit. Heavy sikit, saya akan masuk this one. Ni dah start heavy dah. So minggu ni you cool sikit, baca dulu, buat revision sikit tentang steam distillation, okay? Flash distillation, batch distillation, continuous distillation, sebab you dah belajar. So saya akan terus buat comparison supaya you terus faham the differences and the application. Okay, so saya akan cover ni minggu depan. So lepas ni you siapkan you punya assignment. You ada kelas dengan saya Khamis kan lagi satu? Ya ke? Tak ingat lah. Apa? Esok saja. Esok lah.
Sejam.
Esok je kan? Hantar esok, lepas tu kita jumpa minggu depan. Yeah? Okay. Right? Okay, I think that's all for today. Thank you very much for being here and listening to me. Ada apa-apa, you let me know, Okay, Syam? Okay, right. Okay, Assalamualaikum.
Assalamualaikum.
Okay. So, saya leave,